Welcome everyone to the What Happens When channel, where everyday questions are answered. Before we get into it, why don't you hit the subscribe, like, and smash the notification bell? Okay, let's do this. Did you know that right now, as you're listening to this, your body is generating enough electricity to power a light bulb? It's a fascinating revelation that showcases the remarkable efficiency of human biology. And today, we're diving deep into the electrifying world of bioelectricity that exists within each of us. Every second, your body conducts an intricate ballet of electrical processes that keeps you alive and functioning. This isn't the kind of electricity that powers your home, but rather a sophisticated network of biological electrical currents that flow through every cell in your body. The human body generates approximately 100 watts of power through its normal biological functions, comparable to the energy needed to illuminate a standard light bulb. This biological electricity generation begins at the cellular level, where specialized proteins called ion channels create electrical potentials across cell membranes. These channels act like microscopic gates, controlling the flow of charged particles, primarily sodium, potassium, and calcium ions. When these ions move across cell membranes, they create tiny electrical currents that, when combined across billions of cells, add up to significant amounts of bioelectrical activity. The most dramatic example of this biological electricity at work is in your heart. Your cardiac muscles rely on precisely timed electrical signals to maintain their rhythmic contractions. Each heartbeat begins with an electrical impulse generated by specialized cells in your heart's natural pacemaker, the sinoatrial node. This electrical signal then cascades through your heart muscle, coordinating the contractions that pump blood throughout your body. Your nervous system is another remarkable electrical network. Neurons communicate through electrical impulses that travel at speeds up to 268 miles per hour. These signals enable everything from conscious thought to unconscious reflexes, creating a biological information superhighway that makes computer networks seem primitive by comparison. What's particularly fascinating about this biological electricity is its incredible efficiency and resilience. Unlike mechanical systems that often require maintenance and experience significant energy loss, your body's electrical systems are self-maintaining and remarkably efficient. They operate continuously for decades, adapting to changing conditions and repairing themselves when damaged. This natural efficiency has caught the attention of scientists and engineers working on sustainable energy solutions. The way our bodies generate and use electricity offers valuable insights for developing more efficient and resilient power systems. Just as our bodies use decentralized networks of cells to generate and distribute energy, future power grids might benefit from similar distributed approaches. Consider how your body's electrical systems operate on a local level, with each cell contributing to the larger whole. This decentralized approach ensures that damage to one area doesn't compromise the entire system. Now imagine applying this principle to our power infrastructure. Instead of relying solely on large, centralized power plants, we could develop networks of smaller, interconnected power generators, each contributing to the grid's overall stability. The parallels between biological electricity and sustainable energy solutions become even more intriguing when we examine the concept of emergence. How complex systems arise from simpler components working together. Your body's electrical activity emerges from countless microscopic processes, just as sustainable energy solutions might emerge from combining various small-scale power generation methods. However, this brings us to a crucial dilemma in energy technology: the tension between centralization and decentralization. Our current power infrastructure relies heavily on centralized generation and distribution, while our bodies demonstrate the effectiveness of decentralized systems. This contrast raises important questions about how we might bridge this gap and what we can learn from biological systems to improve our energy technologies. The human body's electrical processes offer valuable lessons in resilience and adaptation. When one pathway becomes blocked or damaged, biological systems often find alternative routes to maintain essential functions. This adaptability could inspire more resilient energy systems that can automatically reroute power during outages or adjust to changing demand patterns. Moreover, the efficiency of biological electricity generation suggests new possibilities for energy harvesting. Scientists are already developing technologies that can capture and utilize the electrical energy generated by human movement, body heat, and even the natural electrical potential of our skin. While these technologies are still in their early stages, they represent promising steps toward harnessing our body's natural electrical capabilities. As we face growing challenges in sustainable energy production, The human body's electrical systems serve as both inspiration and proof of concept for innovative solutions. The fact that every human body contains this sophisticated electrical network reminds us that nature has already solved many of the problems we're currently grappling with in energy technology. Looking ahead, the intersection of biological electricity and technological innovation opens exciting possibilities. By understanding and emulating the principles that make our body's electrical systems so efficient and resilient, we might discover new approaches to sustainable energy production and distribution. Our bodies demonstrate that it's possible to create reliable, self-maintaining electrical systems that operate continuously with minimal waste. The next time you think about electricity, remember that you're not just a consumer of electrical power, you're a generator of it. Your body's remarkable electrical systems represent billions of years of evolutionary refinement, offering valuable lessons for our technological future. As we continue to search for sustainable energy solutions, perhaps the most powerful inspiration lies within our own cells, silently generating the electricity that keeps us alive and functioning, one ion channel at a time. Thanks for watching.